This video is on geometric sequences. We're going to try something a little bit different called Zaption. You'll be able to answer some questions along the way of this video, so let's get started. So here we have some vocabulary for geometric sequences. Geometric sequence is just like an arithmetic sequence. The only difference is now you have a common ratio, a constant multiplier, rather than a common difference. Here I've included also the definition of the geometric mean in case you're trying to find a value in between a sequence, but you don't have that common ratio given to you. I've also included the geometric sequence formulas. For the most part, we will be using the explicit definition, which will be taking the first term times the common ratio to the power of n minus 1. So how do you find the ratio between consecutive terms? Well, you take your second term, your common ratio, we're going to call it R. So you take your second term divided by your first. It should be equal to your third term divided by your second, your fourth term divided by your third, and it should be constant throughout. So here you get 2, here you get 2, and I divided here by the wrong term. Here you also get 2. So the common ratio here would be 2. So let's try identifying geometric sequences. So for the first example, first we have to find our common ratio. Make sure that it's common throughout. To get from 3 to 6, we multiply by 2. 6 to 12 by 2. 12 to 24 by 2. So our common ratio here is 2. So our sequence would be our first term times our common ratio, and then n minus 1. And I have the formula up here for you. Let's try another example. So R will equal to get from 3 to negative 9, we multiply by a negative 3. Negative 9 to positive 27 is a negative 3. And so on and so forth. So the common ratio here is negative 3. So our formula here is an times 3, which is our first term, times common ratio, which we'll put in parentheses to not lose that negative, negative 3 to the n minus 1. Try parts C and D on your own. Hopefully those two weren't too bad. Let's look at example 2. Find the indicated terms of the geometric sequences. Well, they're already telling us that they're geometric sequences. So first we have to find the common ratio in order to find the formula, in order to be able to find the sixth term. So our common ratio here would be negative 5. Our formula would be 3 times parentheses negative 5 to the n minus 1. And now we can use it to find the sixth term. So A6 is equal to 3 times negative 5. 6 minus 1 is 5. That'll give us negative 9,375. Try part B on your own. Okay, let's look at example 3. When radioactive substances decay, the amount remaining will form a geometric sequence when measured over constant intervals of time. The table shows the amount of adamantium as a highly radioactive element initially and after 2 hours. Find the amounts left after 1 hour, 3 hours, and 4 hours. Well, in order for us to be able to do this, we first have to use the geometric mean, which is take just the square root of your first term times your second term in this case. And that actually gives us 711.95, which will round off to 712. Geometric mean will give you When given two values, take the square root of the product of those numbers, and that'll give you the value in between. Well, now that we know that value, we can now find our common ratio, and we can take our 712 divided by the value given initially. And that gives us a ratio of 0.539, which will continue. So now we can write our geometric sequence formula. So AN will equal 1,320 times 0.539 to the power of n minus 1, and use that to find our next terms, which are 207 and 112. I've given you again the geometric mean formula, which simply states the geometric mean of two positive numbers, x and y, is the square root of the product of those numbers. In a sequence, the formula is given to you as is so here. If we look at this example here, if we take the square root of 4 times 16, well, that's simply the square root of 64, which is plus or minus 8, which is the value we have in the middle. Again, if we take negative 8 times negative 32, then that gives us the square root of, I'm not too sure what that is, which will then give you plus or minus 16, which is the value you have there. So let's use that formula in order to find, by using the geometric mean to find the following. So here we'll take the square root of 45 times 80, which will give us the square root of 3,600, which will equal to 60. And that's what will go inside. Try example B on your own. I hope that these examples that I've done along with you and the ones that you've tried on your own have helped you get a little bit of a better understanding of geometric sequences. Please continue to watch the next video, which will be on geometric series, and I'll see you soon.